In this example, we're going to divide a polynomial in the numerator by a monomial in the denominator, and we're going to simplify. It's important that there's a monomial in the denominator because with that there, we're able to write the entire expression as fractions. We're going to break it apart and write it as fractions. So write the expression down and count the terms in the numerator. There's 1, 2, 3, 4 terms in the numerator, and we're going to write a separate fraction for each term, and each fraction is going to have 2x to the third in the denominator. So your first one's going to be 6x to the fifth over 2x to the third, and so on. Each fraction is separate, and I'm putting pluses in between the fractions because there are pluses in between the terms in the numerator. The next thing we need to do is reduce all of those fractions that we wrote. So let's write the fractions out, and you're going to reduce the numeric part and the variable part. So the numeric part of the first fraction, if I cross the 6 and the 2 out, I can write a 3 on the top. In the first fraction as well, we have x as a base, and we've got two exponents, the 5 and the 3. But 5 is the bigger exponent, so we're going to subtract the 3 up top, and it just removes that 3 from the bottom. In the second fraction, the 9 and the 2 do not reduce, but the x squared and x third will. And again, we're going to go where the bigger exponent is, and this time it's in the denominator. So we're going to mark the x squared out from the top and subtract that 2 on the bottom. In the next fraction, reduce the numeric part by writing a 2 on the top, and your variables are exactly the same, so those will cancel each other out. And finally, in the fourth fraction, we're going to reduce the numeric part by writing a 4 on the top, and the x third has to stay in the denominator. So we've done all of our reductions, and now we have to write the reduced fractions. And when we do that, we have to make sure we honor the new numerators and denominators. So we can't move anything around. We're just going to keep everything where we had it when we did the simplifying. So the first fraction has the 3, and then it's going to be x squared after I subtract 5 minus 3 for that exponent. I didn't have a denominator in that first one, so I'm just going to leave it by itself. It doesn't need a denominator because I marked the entire denominator out. The second fraction is going to have a numerator and denominator. The 9 is going to be in the numerator, and in the denominator we've got 2. We also have just an x because 3 minus 2 is 1, and we don't have to write an exponent of 1. In the third fraction, we've got just plus 2 because all of the numeric parts had been canceled, leaving the 2, and there's no variables left, and there's also no denominator. The fourth fraction has a numerator and denominator. It's going to be a 4 in the numerator and x third in the denominator. And this is our final solution. It's all simplified and broken apart from the original. So there's your answer.